All right, so now we're going to be talking about logarithmic functions. We just talked about exponential functions, but what we want to do is logarithms. So here's the thing. Log of the base of the number equals the exponent, whereas exponential is base to the exponent equals the number. Those of you who have had me for Algebra 2 remember this. It's the log of Benny is the inverse of Ben, okay? So it says changing from a logarithmic to exponential form and finding the missing value. Okay, so it says if the logarithmic form is not already in equation form, set it equal to y or x, doesn't really matter. Rewrite the base raised to a power, y equals x. Find the value. So here's the thing. If I set this equal to x and I change it from the log of Benny to Ben, the base is 2, the e is the x, and then the n is 4. So you get 2 to what power equals 4? 2. So the log base 2 of 4 is 2. Okay? So this is asking you 4 to what power equals 64? 3. Now this one, you get 2 to the 5th equals x, because again, B, N, E. Change it to Ben. Goes from log of Benny to Ben. So you get x equals 32. Okay? So again, to solve these, you change from the log of Benny to Ben. Okay, let's keep going. All right, so here it's saying 3 to the 6th equals x. Just put that in your calculator. Here it's 3 to what power equals -1? Well, there isn't one. There's no solution. You can't do the log of a negative. If you try to do the log of a negative number in your calculator, it's going to tell you error. And it also can never equal 0. So if we look at the next one, 4 to what power equals 0? And this is why. You can never start with a number to an exponent and have it equal 0, because 4 to the 0 is 1. So again, no solution. This one is 10 to what power equals 100? So it's just 2. Okay? And log base 10 is what your calculator will do. And another way, it's just log. Those are the same thing. Okay? All right, let's keep going. So here now, if we try to convert this and say 10 to what power equals 2.5, no idea. But see how it's log base 10? So in your calculator, you just hit log 2.5, hit enter. If you do that, you should get 0.3979. Okay? All right, now we're dealing with graphs. So it says to graph the function f of x equals log. So think about it this way. And then if you switch the x and the y, and we solve for the y, you end up with g of x here. You get 2 to the x equals y. Okay? So if this we can plug into our calculator and easily graph and easily get. So what we want to do, though, is to graph these is you switch. So these are your y values. These are your x values. Because see how back here we switched the x and the y? So when we go to graph the log function instead, because that's what they want us to graph, make these your x values and these your y values. So you go 1/4, -2. And then you go 1/2, -1. And then you go 0, 1. And then you go 1, 2. 2, 4. And then 8. Oh, wait, hold on. Had to make some corrections there. Should have been 1/4 -2, 1/2 -1, and then 1 0, then 2 1, then 4 2. Now we're going 8 and 3. So it ends up looking like this. And if you think about the standard log function, okay, there's always a vertical asymptote at x equals h. See how there was no h here? So it's never going to cross that 0. So there's our graph. Wouldn't worry too much about these, but just in case. Okay, let's keep going. All right, so we're going to use these properties. Natural log of 1, 0, because e to the 0 is 1. Natural log of e is 1, because e to the first is e, and natural log of e to the x is the x. So see how here we have natural log of e to the third. What's the exponent? So it's 3. Because if I set this equal to x, and I changed it, natural log is log base e. So that if I changed it, it'd say e to the third equals e to the x. So x is 3. So here, this would be natural log of e to the -2, so it's -2. Here, it's the natural log of e, so it's 1. Okay? If you don't get these, I'll do some more examples in class. You got to ask, because you watched the notes. Okay. So now change your base formula. See how your calculator only does log base 10. So see how it's log x over log a, or natural log x over natural log a. So this one here, you can calculate two ways. You can do log 5 divided by log 3, which is the same thing as saying natural log of 5 divided by the natural log of 3, because these are in your calculator to be able to do. Okay, let's keep going. Alright, so it says use the change of base to evaluate. So that, again, that means you can do log 36 divided by the log of 9, or you can do the natural log of 36 divided by the natural log of 9, whichever button you want to hit. Here, you would do the log of 2 plus e to the third over the log of 4, or you can do the natural log of 2 plus e to the third over the natural log of 4. And here's the thing, you can just enter these into your calculator right now. All you got to do is make sure you get parentheses in the right area to make sure you're calculating the right things, okay? Alright, so there's basic introduction of logs, and followed by the exponentials. And then we're gonna see some relationships in the next lecture as well. Alright, we'll see you then.